Right. Okay. So today is the first day of our paper class, right? So don't worry. You will get the hard copy of the paper book by next Monday. Since this is the first week, no issue. So you just listen and try to get an idea about the paper class and the questions that we're going to discuss, right? And you have the PDF. You know what are the questions that you have. I believe that you have tried at least few questions in the first paper, right? Okay, then let's start. So the first paper that we are going to discuss is 2017 Royal College paper, right? So this is the very first paper that we are going to discuss. Remember, so the intention of you have to understand before we go for the discussion. Listen to this one. The intention of conducting this paper class is to prepare you for the first term examination that they are going to conduct in your school, right? So our target is first term test exam, right? I told you that always, I have already told you that always my students should get highest mark in your schools, right? If you have learned the theories properly and if you have done enough papers, definitely you can score the highest mark for the first term test examination that they're going to conduct in your school, right? So remember, your first term test examination is going to conduct using 3 units. Unit number 1, unit number 2, and unit number 3. Structure and bonding, second unit. Third unit, chemical calculation. Currently, we are doing these 2 units, and we have already finished the first unit, atomic structure. So these 3 are the units. Actually, you will get the questions in your examination, first term test examination. So in this paper book, there are questions from all 3 units, right? So don't worry whether you have learned the theory or not. Doesn't matter. In this paper class, we are going to revise, we are going to recall the theory points, and we are going to discuss questions, right? So therefore, this is very easy thing. So practice questions, try to get an idea about the question patterns, right? Now, let's move for the first question that they have given. And I suggest you to use a book, right? You can use a book to write down every theory points, every important things that you can note down, right? First question. So what is the first question they have given? Number of elements exist in the gaseous state as diatomic molecules at room temperature 25 degrees Celsius and under the atmospheric pressure 10 to the power 5 newtons per square meter is, right? So remember, when we analyze the periodic table, there are 11 gases. Can you remember we have learned these things in the periodic table? There are 11 gases. What are the gases we have? Hydrogen, helium, nitrogen, oxygen, fluorine, neon. And then if you go for the third period, then we have chlorine, argon, krypton, xenon, radon. So these are the gases in the periodic table. There are 11 gases. Can you remember? Hydrogen, helium, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon, radon. If you count them, 4, 8, 11, there are 11 gases. But remember, students, they are not asking number of gases. Here they are asking number of elements exist in the gaseous state as diatomic molecules. So what are the gases actually existing as diatomic molecules, right? Hydrogen, is it a diatomic molecule? Yes, the natural existence of hydrogen is H2, H2 molecules. Helium, no, helium is not a diatomic molecule, but nitrogen is a diatomic molecule, N2. Neither. So nitrogen is existing as a diatomic molecule. Diatomic molecule means there are 2 atoms. And the next one is oxygen gas, O2. And next one, fluorine gas, F2. Right? So all of them are existing as diatomic molecules. What about neon? No, neon is not possible. Chlorine, yes, chlorine is existing as diatomic molecule. Argon is not, krypton is not there, xenon, radon, they are not diatomic molecules. So the diatomic molecule gases that we can see in the periodic table is hydrogen, nitrogen, oxygen, fluorine. So there are 5 elements, right? So question number 1, answer is third one. So this is the theory point. This is the theory point you have to remember. Okay. So take out your books. If you want, you can note down these theory points. So you can collect theory point. In this paper, I have note down this much of theory point. Theory point 1, theory point 2, 3, 4, likewise, you can collect the theory points, right? Right. So look at the first question. First question is really easy, né? Huh? Let's go for the second question. Let's move for the second question. So the second question is, what is the total number of unpaired electrons in M2 plus ion of the element having the atomic number 25? So they're asking, what is the total number of unpaired electrons in M2 plus ion? Right, atomic number is given as 25. Let's move for the question number 2. So in question number 2, right, in question number 2, they have given an element. Atomic number is 25, right? First of all, let's write down the configuration. Let's write down the configuration for atomic number 25. We have learned the electron configuration. Can you remember? So the electron configuration for atomic number 25 is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s2. So you can count here 10, 20, 25. So 25 electrons are there. And they're asking how many unpaired electrons in M2 plus cation. So M2 plus cation means after removal of these two electrons, we can form M2 plus cation. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. So this is the electron configuration for the M2 plus cation, right? So we know that these electrons are paired electrons. All the sub-energy levels are completely filled except 3d sub-energy level, right? 1s, 2s, 2p, 3s, 3p, these sub-energy levels are filled with electrons except 3d. If you consider 3d5 configuration, there are 5d orbitals, 1, 2, 3, 4, 5. Each and every orbital is filled with just one electron, unpaired electrons. So you can see that how many unpaired electrons are there in M2 plus cation? There are 5 unpaired electrons. Neither. So therefore, we can see that in M2 plus, atomic number, which is atomic number 25, is having 5 unpaired electrons. 5 unpaired electrons. Okay. So question number 2, answer is first one. Question number 2, answer is first one. Sorry. So can you tell me what is the element? Can you tell me what is the element capital M? Akash, yeah. What is the element capital M? 25 electron configuration? Yeah, correct. You all are correct. What is the configuration? What is the element? Manganese. Manganese is the element. Eh? So they have indirectly asked about manganese. How many electrons on how many unpaired electrons are there in manganese? Mn2 plus cation, right? Okay, let's revise the theory. As the theory point, let's revise 3D elements configuration. Can you remember 3D elements configuration? There are 10 elements in the third period. 3D elements. What are the elements? Scandium, titanium, vanadium, chromium. Can you remember? Manganese, iron, cobalt, nickel, copper, zinc. So these are first unit theories, very easy theories. Okay, so while doing this question, let's revise the theory point, the second theory point, 3D series elements. Quickly write down the configurations. Okay. Just remember, these things are very easy, right? These questions are very easy. Continuously do the questions, then you will realize doing a paper is nothing, right? Theory is different, paper is different. If you think that doing theories are always equal to what? Getting highest marks, It's not the case, right? So therefore, you have to practice papers. Then only you can score well. Theory point. So the theory point that we are going to learn here is 3D series elements. Electron configuration. So what is the electron configuration? So what are the elements first of all? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. In unit number 6, we are going to discuss about these elements separately. What are the colors? What is the aqueous solution color? What is the amine complex color? What is the chloride complex color? Everything we are going to learn under 6th unit. Atomic numbers 26, 27, 28, 29, 30. Scandium 1s2, 2s2, 2p6, 3s2, 3p6. So no need to write down these things neither. We can just write down the valence configuration. Let's write down the valence configuration. 3d1, 4s2. So this is 3d2, 4s2. Vanadium 3d3, 4s2. Chromium 3d4, 4s2. And then manganese 3d5, 4s1. Iron. Chromium's configuration, is that correct? 3d4, 4s2. Is that correct? No, I told you that chromium's configuration is rearranging 2, 3d5 and 4s1. Chromium's configuration is very important, right? So it's going to convert into 3d5, 4s1. So iron, we can write down 3d6, 4s2. Cobalt, 3d7, 4s2. Nickel, 3d8, 4s2. So copper is 3d9, 4s2 that we are expecting, but it's rearranging into 3d10, 4s1. And here zinc is 3d10, 4s2. So this is the theory point, right? This is the theory point. 3d5, 4s2, right? Manganese is 3d5, 4s2. Okay, Lashmi. Sorry. Done. Okay, quickly. So this is not theory class, huh? So everyone should write it quickly. Right. Now, let's move further. Right, okay. Let's move for the third question. Third question. Types of bonds present in an aqueous solution of ammonium iodide. First of all, you should be able to identify the compound ammonium iodide. Can you remember that? Can you remember ammonium iodide? We learn how to write down the chemical formulas when they have given the names. Can you remember it? Ammonium iodide. So remember, students, ammonium iodide. So it's like this. So this is ammonium iodide. Right? This is ammonium iodide. So they're asking here types of bonds present in an aqueous solution of ammonium iodide are. Right? So let's consider what is the cation and anion in this compound. The cation in this compound is NH4 plus. Anion in this compound is I minus. Ammonium cation and iodide anion. So first of all, we have to understand that we have here cation and anion. If there is a cation and anion, so which kind of a bond is existing there? If there is a cation and anion, which kind of a bond is that? Ionic bond. If there is a cation and anion, definitely that one should be ionic bond. So therefore, in ammonium iodide aqueous solution, definitely, right? Definitely, ionic bonds are there. Ionic bonds are there. Ionic bonds are there in ammonium iodide aqueous solution. So they have given few answers, right? Covalent bonds, ionic bonds, hydrogen bonds, iron dipole bonds, and dative bonds. What do you think about that? Remember, students, in the second unit, I taught you interactions. So this is the theory point. We learn when you categorize the bonds or interactions, there are two types. So what are the two types of interactions we learn? Primary interactions and secondary interactions. Okay, so there are four types of primary interactions: ionic bonds, covalent bonds, dative covalent bonds, and the next one is metallic bonds. Right? So these are the four types of primary bonds. And if you consider the secondary interactions, I told you that there are few types of secondary interactions. First one is iron dipole interactions. Iron dipole interactions. And the next one is iron induced dipole interactions. Induced dipole interactions. You don't have to, right? I didn't teach you this one in detail, but you know the names, right? I told you the names of the secondary interactions, right? Iron dipole interactions, iron induced dipole interactions. Next one, dipole interactions, right? Next one is dipole interactions and hydrogen bonds. Then we have dipole induced dipole interactions. So the last type is London dispersion forces. London dispersion forces. So these are the 5 secondary interaction types, right? So look at this one. We have to identify what are the bonds in this ammonium iodide aqueous solution. We know that mainly, since there is a cation and anion, ionic bonds are there, right? So what about ammonium cation? What do you know about ammonium cation? We know that ammonium cation, we drew the Lewis structure for ammonium cation. Can you remember? Students, that means in ammonium cation, NH4 plus cation is there, NH4 plus. So these are dative covalent bonds. Covalent bonds. These are covalent bonds. And there is a dative covalent bond also. Under dative covalent bonds, I told you that ammonia is giving lone pair for the H plus cation. H plus cation is electron deficient species. Actually, H plus is not containing any electron, 0 electrons. So therefore, ammonia is giving electrons for H plus, and it's forming dative covalent, and covalent bonds are also there. Which means in ammonium iodide solution, ionic bonds are there, covalent bonds are there, dative covalent bonds are there. What do you think? What do you say? Am I correct? You can argue with me, right? If I'm wrong, I'm saying that in ammonium iodide compound, ionic bonds are there. The reason is ammonium is a cation and iodide is an anion. So the attraction between cation and anion is ionic bond. And then I'm telling that ammonium cation is made by ammonia and H plus. So ammonia is a covalent compound, covalent bond. So therefore covalent bonds also there. And H plus ammonia, it's forming dative covalent bond, right? Therefore dative covalent bond. So the main 3 primary interactions are there in this compound. Now let's move for the secondary interactions. If you move for the secondary interactions, interestingly, okay, now you are going to learn secondary interactions. Look at this one, how easy these things are. They have given ammonium iodide aqueous solution. Remember, if it is ammonium iodide aqueous solution, ammonium iodide and water molecules are there. Students, aqueous means it's representing that water molecules are there. Aqueous means it's representing that water molecules are there, right? Then we can say that, look at this one, they have given covalent bonds, ionic bonds, dative bonds also there. What about hydrogen bonds? Students, remember, water molecules are forming hydrogen bonds, right? So you have to remember that hereafter, water molecules, H2O, is forming hydrogen bonds, right? So what does mean by hydrogen bonds? Yeah, very easy. Hydrogen bonds means electronegative atoms like oxygen, nitrogen, fluorine, when they are connected to hydrogen atom, right? When they are connected to hydrogen atom, so these kind of groups are again connecting to same kind of OH, NH and HF group. So then they are forming hydrogen bonds. We know that in water molecule, OH group is there. Since there is a OH group, water molecule is forming hydrogen bonds, right? We are going to learn these things in detail, theories. But in order to do this question, this is enough. Water molecules are forming hydrogen bonds. That's all. And the next one, right? Look at this one. Water molecule and ammonium plus cation. Remember, students, I told you that ammonium plus cation is positively charged. That's an ion. And water molecule, what do you think about water molecule? Water molecule is actually a dipole. What is that dipole? Polarization. Polarization. Polarization means we know that the bond is polarized. Now, if you consider water molecule is polarized one, right? That's a polar molecule. So that polar molecule is connecting to ammonium plus cation in order to form ion dipole interaction. So as you can see here, under the secondary interactions, we have ion dipole interactions and hydrogen bonds, right? So in the answer they have given types of bonds present in an aqueous solution of ammonium iodide are simple A, covalent bonds. Is that correct? Yes. Simple B, ionic bonds. Is that correct? Yes. Then hydrogen bonds. Is that correct? Yes, of course. Ion dipole, I told you that ammonium plus cation is connecting to water molecule. Ion dipole bonds are correct. Then dative bonds. Yeah, that's also correct. Ne? So therefore, all the bonds are existing. So therefore, question number 3, answer should be fourth one. Question number 3, answer is fourth one. Right? So this is the theory point. That you have to remember. Right? Very easy. Interactions are 2 types, primary and secondary. Ionic covalent, dative covalent, metallic bonds are primary. And secondary interactions are in this way. Okay. So quickly copy down everything that you want. So that is the third question. So how that ionic dipole came? Right. Okay. Remember, water molecule is dipole molecule. Dipole molecule means you can see that there is a polarization. Oxygen is pulling electrons. Oxygen is pulling electrons. Therefore, oxygen is delta minus, hydrogen is delta plus, and here delta minus, delta plus. Right. So therefore, a polarization is there. Actually, the polarization is towards upward. Oxygen is pulling electrons. Right. So therefore, there is a dipole. That means polarization there means this is dipole molecule. Polar molecule. Polar molecules, non-polar molecules. Now look at this carbon dioxide. Carbon dioxide is non-polar molecule. Why is that? Oxygen pulling electrons from this side and this oxygen is pulling electrons from this side. So they are cancelling off. Right? But here oxygen is pulling electrons from hydrogen from both sides. There is a polar bond. So this polarity, that means this polar bond is connecting to the ammonium plus cation because oxygen is negatively charged. Oxygen is negatively charged. That negatively charged oxygen is connecting to ammonium plus cation. And hydrogens are positively charged. This hydrogen positive charge can be connected to negatively charged imides. So try to understand. That's why I told you that ion dipole interactions are existing. Students, don't think about these things so much, too much. Just get an idea. If you can't understand, we are going to discuss these things anyway in theory detail. This is to practice you for the questions, right? So therefore, learn something. That's enough. Nothing to worry, nothing to be afraid, nothing to be panicked. Everything we are going to learn. Okay. Okay, are we done? Any doubts? Anything? No. Right. Now let's move for the question number 4. Question number 4. Question number 4 is related to redox. This question is really easy. Let's see. Ethanol is oxidized to acetic acid by a strong oxidizing agent, KMnO4 in acidic medium. Changing the oxidation number of the carbon atom is given in. Very easy, right? Can you remember we discussed this kind of a question in last year 23 paper, this January paper, right? So that paper is also containing this kind of a redox question. So these things are very easy, right? We balance so many redox reactions in acidic medium, basic medium, using the short method, then half reaction method, everything we learn. So therefore, this type of a question is very easy for you, right? Then let's see. They have given ethanol C2H5OH. So this is oxidized to acetic acid in the presence of potassium permanganate. They are not asking us to balance this one. They're asking what is the change in the oxidation number of carbon atom in these two compounds, right? And here probably the product should be Mn2 plus and water, because we know that in the acidic medium, permanganate cation is going to convert into Mn2 plus. I told you that one, right? Now this is very important. The thing is, since there are two carbon atoms, you are trying to take the average oxidation number, and here also we are trying to take average oxidation state, right? But I'm going to show you something here, very important. If I draw the structure for ethanol, so this is the structure for ethanol. If I draw the structure for ethanoic acid, if not, we can say acetic acid, CH3C double bond OH. So this is the structure for ethanoic acid. So oxidation number. Let's see that how is the oxidation number is going to change. Tell me, what do you think? This carbon atom's oxidation number is hydrogen plus 1, carbon minus 1, plus 1, minus 1, plus 1, minus 1, minus 3, isn't it? And if I consider this carbon atom, what is the oxidation state? Same as the ethanol, here also carbon atom's oxidation number is minus 3. Ne? You can understand that. What about this carbon atom? If you consider this carbon atom, oxidation number is hydrogen plus 1, minus 1, plus 1, minus 1, oxygen minus 1, plus 1. Therefore, oxidation number is minus 1 for this carbon. And what is the oxidation number for this carbon? Minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. Plus 3. You can see that the first carbon atom in both compounds, the first carbon atom, that means in CH3 group, there is a carbon atom. That carbon atom has not changed its oxidation state. Minus 3, minus 3. But if you look at the second carbon atom has clearly changed its oxidation state to from minus 1 to plus 3. Can you understand? Can you understand that? Very easy. So the question they're asking here, ethanol is oxidized to acetic acid by a strong oxidizing agent KMnO4 in acidic medium. Change in the oxidation number of the carbon atom is given in. What is the change in oxidation number? Minus 1 to plus 3. Because the other carbon atom is not changing oxidation state. You don't have to worry about this carbon, because in both compounds, their oxidation numbers are same. But the other carbon atom changing oxidation state from minus 1 to plus 3. Students, if you're trying to take the average oxidation number, you won't get this answer. Right? So therefore, we have to be very careful in these kind of questions. Right? You have to see that actually. Remember, ethanol can be written as CH3, CH2OH. අපිට ethanol මෙහෙම ලියන්න ඕනේ. ඒතර මෙතන CH3 එකයි, මෙතන CH3 දෙකයි, දෙකම එකයි වගේ. Both are same. So then you have to look at the other carbon atom. So therefore, answer is minus 1 to plus 3. Question number 4, answer is plus 1. That's very easy. If you have any doubts, please let me know. Akash, any doubts? ප්‍රශ්න ඉදන් අහන්න හරි. Right, okay. So any doubts, anything related to question number 4? Right. Now let's move for the question number 5. So can you send me the answer for question number 5? Because that's really easy. Send me the answer. Which of the following pairs match correctly? Yeah, let's see what are the answers in the chat box. Yeah, Mariam is correct. What about the others? Sinitma correct. Nasma correct. What about the others? Question number 5. Fourth one, yes. Yes. Question number 5. Answer is fourth one. That's correct. Hmm? No, not fifth one. Why? Atomic model. Who discovered atomic model first? Yeah, Thomson also discovered atomic model. What is that? Plum pudding model. But here they are asking, here they are trying to ask here, who found the atomic model at first? Dalton. That's what Thomson naming, right? So let's go for the question number 5. Question number 5. The first statement they have given, discovery of electron. So discovery of electron. Who discovered the electron? J.J. Thomson. Next one, naming proton. Who named proton? Naming proton. Who named proton? Ernest Rutherford. Ernest Rutherford. Number 3, determination of charge of an electron. Determination of charge of the electron. Who discovered the charge of electron? Who discovered charge of the electron? Robert Millikan. Robert Millikan. Robert Millikan, right? Can you remember oil drop experiment? Oil drop experiment. Using the oil drop experiment, Robert Millikan discovered the charge of an electron is 1.602 10 to the power minus 19 coulomb, right? So as a chemistry student, actually you cannot forget these things, right? So if you forget these things, actually you are insulting for yourself. I don't know. So who discovered? So the next one is discovery of neutron. So who discovered neutron? So neutron discovered by James Chadwick. James Chadwick, right? And number 5, students, they are trying to say here, first atomic model. First atomic model. You can correct if you want. That should be first atomic model. So who discovered first atomic model? John Dalton. John Dalton. So you can see that according to the answers that they have given in the question and the correct answers that we wrote here, you can compare them. So the correct answer should be fourth one, isn't it? Question number 5, answer is fourth one. Okay. So in the fifth answer, they are trying to say first atomic model. So the first atomic model discovered by John Dalton. Right. Okay. Shall we move for the next one? Before we go for the next one, I will revise you a theory point that is very important. That is very important for us. Students, what are the atomic models we learn? Let's revise the atomic models. Atomic models. So the very first atomic model was introduced by whom? John Dalton. That is solid sphere model. That means John Dalton said that atoms look like what? A solid sphere. So therefore, that is known as solid sphere model introduced by John Dalton. And the next one, what is the second atomic model? The second atomic model was plum pudding model. Plum pudding model was introduced by whom? Was introduced by J.J. Thomson. J.J. Thomson. Number three, what is the next atomic model? Huh? What is the next atomic model? Yeah, we have doubts. So can we say golf ball model to right? Yeah, we can say golf ball model also. We can say that golf ball model also. That is also possible. Right? So third one is nuclear model. Nuclear model was introduced by whom? Ernest Rutherford. Ernest Rutherford and his students. Who are the students? Geiger and Hans Geiger and Ernest Marsden. Can you remember? We learn these things. Eh? Number four. Number four is Bohr model. If not, we can tell that energy level model. So Bohr's model was introduced by Niels Bohr. And currently, in modern science, we are accepting quantum model. Or else we say that electron cloud model. Quantum model, if not electron cloud model. Right? So who introduced that? Erwin Schrödinger. Erwin Schrödinger. Right? So these are the acceptable atomic models. Solid sphere model, if not golf ball model, introduced by John Dalton. Plum pudding model, introduced by J.J. Thomson. Nuclear model, Ernest Rutherford. Bohr model, Niels Bohr. And the fifth one, quantum model, introduced by Erwin Schrödinger. Right? So this is a important theory point that you have to remember. Right? See, everything we learn, everything we learned in theories. Now, when you're doing these questions, students, you can analyze yourself whether I can remember this one or not. If you can remember these things, okay, you're okay. If you can't remember these things, actually you are not good, right? You're not at a good position. You have to be very panic about your coming examination. So that's why now you can understand in this few minutes how many things we learn, right? Can you understand the importance of the paper class? In few minutes, in few hours, we are learning a lot of things. We are revising all the theories. That's why paper classes are conducted. Paper class, that is the importance of the paper class. In theory class, you just learn theory. In paper class, we are going to revise theories. We are practicing questions. We are practicing time management, everything. Okay. So these are the atomic models, right? Now we can move for the question number 6. Okay, Akash. No need to write down these things, right? We know that. Question number 6. Question number 6 is very interesting question related to calculation. Okay, let's see. Can anyone send me the answer? If you have done that question, if you completed that question, can you send me the answer? Question number 6. Anyone here got the answer? Question number 6. Right. Let's see. This is very interesting. Huh? Anyone got the answer for question number 6? Right. Okay. It's okay. Fine. So they have given that there are 3 components in a container: helium gas, oxygen gas, and magnesium solid. So these are placed in volume 4.157 cubic decimeter volume container at the temperature 300 Kelvin. Right? Volume is 4.157 and the temperature is 300 Kelvin. So they have placed from each gas, they have placed 0.01 moles. Oxygen 0.01 moles. So once we know that mole means actually the simplest parameter to measure the amount in chemistry. You have learned these things in your O-level time also, right? So they have included, they have inserted helium 0.01, oxygen and magnesium also same way. Then what is the number of moles of gases in the container when magnesium is combusted completely? When magnesium is combusted completely. So what does mean by combusted? Combustion reaction. Combustion reaction means reaction with oxygen. Magnesium solid is reacting with oxygen gas to form magnesium oxide. These things are very easy. Right? This is not easy. Easy, right? 2 MgO. Now we are going to balance the reaction, right? Since there are 2 oxygen, we can put here 2. Since there are 2 magnesium, let me put here 2. See, very baba questions, right? These questions are for babies. Now look at this. So this is the combustion reaction. Now let's see initially how much of moles they have added. Initial moles that they have added. From magnesium they have added 0.01. And oxygen, how much they have added? 0.01. Initially magnesium oxide is not there. The second step is reacted and formed amounts. Reacted and formed amount. And here final remaining amount. Let me write down here remaining. Alright, remaining moles. This is very easy. So students, they have given that according to this reaction, 2 magnesium is reacting with 1 oxygen. According to these numbers, these are known as stoichiometric coefficients. Okay, you don't worry about those names. Just understand 2 magnesium is reacting with 1 oxygen. Now we have added 0.01 of magnesium and 0.01 of oxygen. Now can you tell me in which ratio, in which exact ratio magnesium and oxygen is going to react? The ratio is 2:1. Magnesium දෙකක් එක්ක oxygen එකක් react කරනවා. නේ? Therefore, but we have added 0.01 and 0.01 of oxygen. Both are same. Then tell me how much of magnesium reacting exactly? How much of oxygen is reacting exactly? If I write here in this way, look at this one. If I consider 0.01 of magnesium is reacting with half of that 2:1 කියලා කියන්නේ මෙයාගේ half 0.005. Nick, half of 0.01 is 0.005. Here I'm adding negative signs because they are reacting. So formed amount 2. Magnesium and magnesium oxide, same amount, 2:2. Then magnesium oxide, how much? 0.01. Positive. Why positive? Positive is representing formed. May then react kara, may form kara. So therefore reacted amount and formed. Can you understand? Finally, in the system, do we have magnesium? No. Do we have oxygen? Yes. Because initially we have added 0.01 of oxygen. But finally we have only 0.005. So the remaining one, 0.005. Then may the so 0.01 from 0.01 of oxygen, this amount reacted. Then remaining amount is 0.005. Got it? So this is the magnesium oxide also 0. That is 0.01. So after the combustion reaction, now magnesium metal is gone. Magnesium metal is gone. Magnesium is totally consumed. In a reaction, the one who totally consumed is considered as limiting reagent. Limiting reagent or limiting reactant. This is the limiting reactant. මෙයාව වැඩිපුර දාලා මෙයාව අඩුවෙන් දාලා. So therefore this is the limiting reactant, limiting reagent. Magnesium is the limiting reagent. Got it? Now they're asking, what is the number of moles of gases in the container when magnesium is combusted completely? Students, magnesium totally gone. Oxygen, half of the oxygen is gone. Now the remaining oxygen amount is in the system 0.005. Sir, what happened to helium? Sir, what happened to helium? Helium is already in the system. It is not reacting with the others because helium is a noble gas. We have added helium initially 0.01. And now you can say that finally, after combustion, the remaining gas moles, remaining amount of gases is equal to 0.01 plus 0.005. So the summation is equal to 0.015 moles. Question number 6, answer is first one. If you have any doubts, let me know. If you have any doubts, let me know. I will help you. Shape Dakash. Any doubts? Helium is not reacting with anyone. So therefore, even after the combustion, helium is there. Yes. Yes, exactly. No. Number of magnesium moles, magnesium is completely consumed now. Now here we have magnesium oxide. Magnesium oxide is a solid that is 0.01. Now magnesium is gone. Magnesium metal is gone. I told you that magnesium metal is gone. Now magnesium in the form of magnesium oxide compound. Understood? Huh? Yeah, half of the oxygen gone for here, half of the oxygen are remaining. භාගයක් මෙතනට ගිහලා භාගයක් ඉතුරු වුණා. Huh? Where? Yeah, it includes here. මේක ඇතුළේ ඉන්නවනේ. මේක ඇදලා තියෙන්නේ මේ දෙන්නගේ එකතුයි. මැග්නීසියම් and oxygen. එතකොට මෙයාගේ භාගයයි අරයාගේ භාගය. No, don't think in that way. Don't think in that way. That is not the way of thinking, right? Don't think that way. That is not the way. Okay. So why these volumes and temperatures are given? Because these are gases. Normally in gas laws, we are discussing the conditions. The applied conditions for the gases are temperatures and volumes. So therefore, to mention the temperature and volume is important, right? But it's not related to the question, calculations, anything that we are going to do, right? Sir, he will also remain in the container, right? So we want to be yeah, I have added. May I have added helium amount 0.01 and oxygen amount 0.005. Then the total amount is 0.015. Okay, right. Good. Right. Let's move for the next question. Question number 7. Please redo these questions again, because these questions are very important. You will understand when you go for the examination. Mark my words. And I want to admit this one. Actually, I have to tell this one. Those who are not attending for my paper class, 25 paper class, I feel very bad about them, very innocent what to do, because they don't have any knowledge of the examination. So this is examination, right? If you still think that theory is the examination, so what to do? Right. Compound. Let's move for the question number 7. Compound A contains only carbon and hydrogen. 1 mole of capital A gives 3 moles of carbon dioxide and 4 moles of water on combustion. Molecular formula of capital A. Yeah. Yes, Lashmi, your answer is correct. Very good. Your answer is correct. Very good. See, that's the spirit, right? Before I do this one, you have to get the answers. So that's what I'm expecting, right? Yeah, who is that? Mariam? Yeah, correct. Your answer is correct. Very good. Before I do this question, try to get the answers, right? So a compound is containing carbon and hydrogen only, but we don't know how much of carbons and how much of hydrogens either. So 1 mole of A gives 3 moles of carbon dioxide and 4 moles of water. See how easy this question is, right? We don't know how much of carbon is there and how much of hydrogen. Therefore, let me take this one as CX and H1 because we don't know it, right? So this is actually hydrocarbon. These kind of compounds are considered as hydrocarbons. For example, methane. Methane is a hydrocarbon. For example, C2H2, ethyl is a hydrocarbon. So likewise, so this is also hydrocarbon, but we don't know how much of carbon and how much of hydrogen. So that is reacted with oxygen or combustion. Combustion means I told you that reaction with oxygen, right? Combustion means reaction with oxygen. It's forming 3 moles of carbon dioxide, then 4 moles of water. 3 moles of carbon dioxide, 4 moles of water. Then Akash, can you see that? Right? Can you see that how many carbons are there? How many carbons are there? 3. How many hydrogens are there? So therefore X equal 3, Y equal 8. We got the answer. So this compound is C3H8. Right? C3H8 means 3 carbon atoms are connected to 8 hydrogens. In organic chemistry, we are going to learn these compounds. This compound is considered as propane. Propane is containing in LP gas. A gas cylinder. LP gas is containing propane and butane mixture. So this is propane. See, very easy. 3 carbon dioxide moles, 4 water molecules. So you can see that carbons are 3, hydrogens 4 into 2 is 8. So therefore C3H8. So molecular formula is C3H8. Question number 7, answer 7. Seventh one is very easy, nothing. Shall we move for the next question? To balance this reaction, if you want to balance this one, count the number of oxygens. 3 into 2 is 6 and 4. How many oxygens are there? 10. So therefore, how many oxygen I have to put here? 5. Because 5 into 2 is 10. Very easy. Question number 8 is related to the hydrogen emission spectrum. Very easy. So let's see. Let's see what other statement they have given. A Balmer series in the ultraviolet region. Yeah. Do we have any doubts? If you have any doubts, let me know. So in the 8th question answer, number 3 is not given answer. 8th question. I couldn't understand, Senura, right? What you have said, but let's see. Question number 8. Shall we draw a hydrogen emission spectrum as a theory point? Quickly draw. Quickly draw with me. Hydrogen emission spectrum. n equal 1, n equal 2, n equal 3, n equal 4, n equal 5, n equal 6, and n equal 7. Right? Energy levels. So we know that all the transitions, all the electron transitions which are falling to the first principal energy level belongs to which series? Which series is that? Lyman. All the electron transitions which are possible for the first principal energy level is considered as Lyman series. Can you remember that? All the electron transitions which are possible for the first one is Lyman. Okay. So we don't have to go for 1, 2, 3, 4, 5, 6. 6 is enough. Yeah, 6 energy levels are enough. Then we can draw the diagram next. Lyman. And then all the electron transitions which are falling to the second principal energy level is considered as Balmer. Next one, all the electron transitions which are falling to the third principal energy level considered as Paschen. Next one, Brackett and Fund. Lyman series, Balmer series, Paschen, Brackett and Fund. Right. Now tell me, to which series of the electromagnetic spectrum belongs to? Lyman. Lyman belongs to ultraviolet region of the electromagnetic spectrum. Balmer. Balmer, the very first four spectral lines are belong to visible light region. Paschen belongs to IR region. Brackett and Fund also belongs to IR region. And remember, students, specifically these four spectral lines, right? Balmer series. Balmer series first line is considered as H alpha. Ne? Second line H beta. Next one H gamma, blue color. Last one is H delta, violet or purple color. Right? So we can see the first line in the Balmer series in red color, second line in green color, third line in blue color, and the last line in violet. Right? H alpha, H beta, H gamma, and H delta. So you can see that H alpha is corresponding to which electron transition? H alpha, red color one, is corresponding to n equal 3 to n equal 1. Next one is H beta. H beta corresponds to n equal, sorry, this is n equal 3 to n equal 2, n equal 4 to n equal neither. So these things are very easy. Next one. Next one is H gamma. This is H gamma. H gamma corresponds to n equal 5 to n equal 2. Last one is H delta. H delta belongs to n equal 6 to n equal 2. Right? So now let's go for the statements they have given. Balmer series is in the ultraviolet region. Is that correct? No, that is belongs to the visible region. But students, this statement is partially correct. Can you remember in theories I taught you that the very first four spectral lines are belongs to Balmer, right? Red, green, blue, violet. After violet color, electromagnetic spectrum, visible light region is not continuing. After visible light region, violet color, it's belong to ultraviolet. So the next electron transitions in the Balmer series belong to ultraviolet. But I told you, since the very first four spectral lines are belong to visible light region, consider that one belongs to visible light. That's the way. Number two, patterns in spectral lines in emission spectrum and absorption spectrum of hydrogen are identical. Yes, correct. Pattern is same in spectral line. Yeah. So this is energy level diagram. In spectral line, patterns are same pattern, right? Because frequencies are same, energy gap is same. So therefore, second statement is correct. I think that should be the answer. But let's see others also. Transition from n equal 3 to n equal 2 relevant to H delta. N equal 3 to n equal 2 belongs to H delta. Is that correct? No, no. H delta is n equal 6 to n equal 2. N equal 3 to n equal 2 is H alpha. So therefore, that statement is wrong. Difference in energy between n equal 4 and n equal 1 energy levels is same as that of between n equal 3 and n equal 2 level. Energy gap between n equal 4 and n equal 1. Where is 4 and n1? This is the energy gap. This gap is equal to n equal 3 to n equal 2. No, you can see that this gap is that equal to this one. No, right? So that's completely lie. Energy difference between energy levels increases. Energy difference between energy levels increases when moving away from the nucleus. What do you think? Energy difference between energy levels. Energy difference between two energy levels. Is that increasing? Decreasing. That statement is wrong. So therefore, what is the truth? What is the correct one? Correct one is second one. Question number 8 answers second one. Right? What are the doubts you have? If you have any doubts, you can. Right. Let's move for the next question. Question number 9. Question number 8 answers second one. Question number 9. So before go for the question number 9, I want to remind you a few theory points. Look at this one. So this is very simple theory point. Remember, students, in chemical calculations, we have two main equations, right? The first one is simple n equal simple m over capital M. And the second equation is C equal n over V, right? You have already learned these things. Can you remember in your O-level time? I think you have learned, right? Concentration and everything. What does it mean by simple n? Simple n means number of moles, the basic parameter to measure the amount in chemistry. Simple m is the mass. Capital M is molar mass. We know that molar mass of an element is a constant. Carbon is 12, oxygen is 16, hydrogen is 1. Can you remember them? We are using them again in A level. Chemical calculation basic stuffs are very easy, right? So this is actually one of the famous equations that we learn, right? Simple n equal capital M, simple M over capital M. And the next one is C equal n over V. What does it mean by C? Remember, students, C means concentration. Concentration means concentration is the chemical parameter that we use to measure the strength of the solution. Concentration is the chemical parameter that we use to measure the strength of a solution. And N means number of moles, and V means volume. So in order to do this question, these two theory points are enough. These two theory points are very enough, well enough for question number 9. Right, let's go. In question number 9, they have given a sample of hydrated barium chloride, BaCl2 2H2O. So what does mean by this dot? BaCl2 dot 2H2O. That means for the barium chloride compound, two water molecules are connected. That's what meant by this dot. And the mass of this sample is 24.4 milligrams. And they have dissolved this solution, this sample, in a beaker or something, right? Dissolved in water and diluted up to 500 millimeters. We know that, students, 1 millimeter is equal to 1 cubic centimeter, right? So therefore, I will write down this one as 500 cubic centimeter. 500 cubic centimeter. Now, they're asking what is the barium 2 plus content in ppm. Are you very easy? They're asking barium 2 plus content in ppm. Right. I will include another theory point for this one. What is this ppm? ppm? Do you have any idea about ppm? ඔයාලා දන්නවද ppm කියන්නේ මොකක්ද කියලා? ppm. What is it? Sorry? Yes. What is that? Parts per million. Yes, parts per million. How many parts are there for a million particles? If I consider a sample with million particles, how many considered amount is there for corresponding species, right? So in chemistry, for very diluted solutions, right? For very diluted solutions, we consider that 1 ppm is equal to 1 milligram per cubic decimeter. Okay, 1 ppm is equal to 1 milligrams per cubic decimeter. So very diluted solutions. And one more thing I want to remind you that 1 cubic decimeter is equal to how many cubic decimeters, students? 1 cubic decimeter is equal to 1000 cubic centimeters. Okay, these unit conversions are very, very important. 1 cubic decimeter is equal to 1000 cubic centimeters. Now, let's find out what is the barium 2 plus content. So, ppm means milligrams per cubic decimeter. Therefore, what I'm going to do here is, first of all, they have given the mass of barium chloride, hydrated salt. That is 24.4 milligrams. First of all, I'm going to find out the molar mass. Molar mass of barium chloride. Okay, molar mass. Barium 137. There are two chlorines, therefore 35.5 into 2. Plus water molecule. Hydrogen, 4 hydrogens are there, 2 oxygens. So therefore 18 into 2. Remember the unit for molar mass is grams per mole. Okay, that is the unit for molar mass. Now get the summation. What is the summation of these values? I will do it. And 36 here, 7, 4, 14, 1, 21, 20. Yeah. Answer is 244 grams per mole. Students, mass, molar mass. If you know mass and molar mass, what we can find? According to that first equation I have given you. If you know the mass and the molar mass, you can find out number of moles. Neither. If you know the mass and molar mass, you can find out number. Can you understand how did I derive this? Barium ekai 137, chlorine dekai 35.5 into 2, and water molecule, oxygen is 16, hydrogen is 1. So therefore 16 plus 2 is 18. One water molecule is 18. By the time you will remember these things, okay? Then 18 into 2, then summation is 244. Right? So that is the molar mass. Then you can obtain number of moles of this compound. So answer, look at this one. 24.4 milligram කියලා කියන්නේ gram වලින් 10 to the power minus 3. හරි? milligram gram කරන්න 10 to the power minus 3 වලින් වැඩි කරනවා. Milli කියලා කියන්නේ 10 to the power minus 3. Then it is divided by molar mass. Grams will cancel off. Then what is the answer? What is the answer? 1 into 10 to the power minus 4 moles. Barium chloride, these moles are 1 into 10 to the power minus 4. Okay. First of all, come up to here. And if you have any doubts, let me know. Quick. Take your time. Take your time and first of all, come up to here. See how many things we have learned. So this is the advantage of doing papers. Any doubts? Yeah, this ppm value is only used for very diluted solutions. So they have given me in this question, they are diluted this one to 500 cubic millimeters. So therefore, that is only for diluted solutions, right? Right, okay. I will erase this theory point. Right. Now, students, we know that number of barium chloride. So this hydrated compound number of moles, right? So this is actually compound amount. If I ask you what is the barium 2 plus cation moles, that is also same because in 1 mole of compound is containing 1 barium atom. නේ මේ එක compound mole එකක එක barium atom එකයි ඉන්නේ එක mole එකයි. So therefore ratio is 1 is to 1. So therefore barium 2 plus moles are 1 into 10 to the power minus 4. Again, look at this one. Now we need to find out here. Try to understand. So this is 1 into 10 to the power minus 4. Now we need to find out mass of barium 2 plus. How do you find out mass of barium 2 plus? How do you find out mass? According to the equation, simple N over simple M over capital M. Then mass is equal to number of moles multiplied by the molar mass. Right? So therefore, number of moles. What is the molar mass of barium? Barium is 137 grams per mole. So the answer is 137 10 to the power minus 4 grams. Now I can find out barium 2 plus content in ppm. I told you that 1 ppm is equal to milligrams per cubic decimeter. How do you convert this one to milligrams? 10 to the power minus 3 grams is milligrams. So therefore 13.7 milligrams. Very easy. Gram to milligram. Then what is the amount of volume? What is the volume? Volume is 500 cubic centimeter. But remember, I told you that 1 cubic decimeter is equal to 1000 cubic centimeters. Then 500 cubic centimeter is equal to how much of cubic decimeter? Half cubic decimeter neither. Half of that. Divide this one by half cubic decimeter because solution volume is half. Then 30.7 into 2 milligrams per cubic decimeter. Now you can get the answer 27.4 milligrams per cubic decimeter is the answer. These are the calculations you will get at the examination, okay? You won't get Baba calculations. බබ්බුන්ට දෙන calculations එකතු කරන්න ඒවා දෙන්නේ නැහැ හරි. මේවා තමයි chemistry වල දෙන calculations. මේවා හදන්න බැරි නම් exam එකේ questions කිසිම දෙයක් කරන්න බෑ. ඒකින්ද දැම්ම ඉඳලා මේවට ලෑස්ති වෙන්න. From now you have to ready for these things. If not in the examination you have to what? Look at the paper or somewhere, that's all. You can't do the paper. Get ready for the examination. Right. What are the doubts you have? Yes, sir, please explain why is it divided by half cubic decimeter? Yes, that's a good question. Amshi, I told you that. Can you remember, Amshi, I told you that 1 ppm is equal to 1 milligrams per cubic decimeter for very diluted solutions, right? So milligrams per cubic decimeter means mass, milligrams means mass of barium 2 plus, and cubic decimeter means the measurement, that this is a measurement of volume. So mass divided by the volume, right? Mass in milligrams divided by volume in cubic decimeter. So this is actually giving ppm. So volume of the solution is 500 cubic centimeter. I converted that one into cubic decimeter. Then the answer is half cubic decimeter. And mass in milligrams, the answer is 13.7. We got that one. We calculated the number of moles and I converted that one into mass. Then you divide that one by volume, you will get the answer as this. Okay, got it? Good. Yeah, Pranali. So how did the number of moles in barium 2 plus become 1 into 10 to the power minus 4? Yes, good. Now only you are asking questions, right? Very good. You are asking questions means you are trying to learn something. Very good. So barium 2 plus. So this compound mole, Pranal, we calculated these compound moles are 1 into 10 to the power minus 4. Inside this compound, just imagine, we have one compound mole. One compound. Just imagine one compound molecule. We have this one. In that one compound, how much of barium atom is there? Only one, eh? Only one. That means ratio is 1 is to 1. So therefore, barium 2 plus is also 1 into 10 to the power minus 4. Just imagine we need to get chlorine. Since there are two chlorines, I have to multiply this one by 2. Then 2 into 10 to the power minus 4. Got it? That's how I got here barium 2 plus number of moles. Yes. Yeah. Here. No, no, no. This is mass. Yeah, that is barium 2 plus content in ppm. So that is ppm value. That is not concentration. Concentration means number of moles divided by the volume. So this is actually content in ppm. ppm is also one of the ways representing the concentration. But it's not exactly concentration. The main concentration is moles per cubic. Got it? Anything else? Any doubts? Lashmi, we can say in that way. ppm is unit of density. Yes, correct. Okay. because density can be measured in kilograms per cubic meter, grams per cubic centimeter. So so this is also one of the way of density. Yeah, we can say in that. Correct. But that is different units, milligrams per cubic decimeter. So question number 9. What is the answer? Answer is number 4. Right. Okay. I'm going to give you a break. 10 minutes break. Okay. I'll give you a break. 10 minutes. After 10 minutes, let's continue the questions. Okay. Quickly take a break. 10 minutes. Right, shall we start? Now, let's move further. Question number 10. Question number 10 is very easy. That is something related to practicals. At your school, you will do practicals. Then you will realize how to do a practical titration, especially. I'll tell you what does mean by a titration. Question number 10, right? So, question number 10, they have given that titrometric method is a very efficient way of determining the stoichiometry of acid-base reactions. Which of the following steps should be considered in titrations? Friends, in laboratory, we are doing an experimental procedure known as titration. So this process is to determine unknown concentration, unknown volume, or unknown number of moles of a particular compound. For this purpose, we are using some glasswares, right? Especially titration flask. Okay. Secondly, we are using a burette. So this is the stand we are using to hold the burette, right? We are taking one solution for the burette and we are taking another solution for the titration flask. So this is the titration setup. Okay, so this is actually, we can clamp this one. So this is a clamp hold. We have solution here. Titration flask. And this is burette. Okay. So this is the burette hold. This is the setup for the titration. So they have given that which are the correct procedures of doing a titration. Number one, washing the burette only with distilled water. Remember, students, when you are doing a titration, we are washing this burette using distilled water, not only distilled water, but we are going to wash this one using the solutions that we are going to add for the burette. For example, just imagine we are going to do a titration between sodium hydroxide and HCl, right? I told you that titration means a method to find out unknown concentration, unknown number of molecules, unknown number of moles. So we can find out them using a titration. So that is experimental procedure. So sodium hydroxide is a base and here HCl is an acid, right? So we can do simple acid-base titrations. I think you could have done you have done these things in your O-level time also, right? That's a simple thing. Huh? So this is the acid-base titration. So for burette we are taking normally base. Generally we are taking base in burette, and in titration flask we are taking acid, HCl. But we can exchange them. Okay, there is no rule to use base, always base in the burette. We can use, if we want, we can use acid also. But mainly, generally, commonly, we are using base in the burette. Okay, try to understand. So, we have to wash the burette, first of all, using distilled water. What does mean by distilled water? What is the specialty of distilled water? What is the difference between water, simple water, tap water and distilled water? Tap water and distilled water. In tap water, we know that ions are trapped. Ne? Ions are there. Tap water wala ions තියෙනවා. එක ions. But in distilled water, that is pure water. No ions dissolved in distilled water. That is pure water. So, first of all, we have to wash this burette using distilled water. And then from the solution, we are going to add to this burette. For example, base, sodium hydroxide. Sodium hydroxide කියන base එකන burette එක හොදන්න. We have to wash it, right? And in the same way, titration flask, first of all, we are going to wash that one using distilled water, right? Actually, we are washing this one using tap water first of all. ඉස්සල්ලා මොනා කරන්න tap water එකෙන් තමයි හොදලා ඉන්නේ. but then again distilled water, and then only from the solution that we are going to add for the titration flask. Okay, so that is the way of we are going to wash these glasswares before we do a titration. Can you tell me a reason? Can you tell me a reason why we are going to wash this one from the solution that we are going to add for that glassware? That means, for example, if I consider this burette, why should I need to wash that burette using this base? What is the reason? Huh? In order to reduce the titration errors. Just imagine inside burette, water molecules are there, water is trapped there. Then you won't get the correct amount of volume neither. So therefore, we need to get the accurate values. That's why we are going to dissolve these glasswares using the corresponding solutions we are going to. Got it? So according to that way, the first statement, washing the burette only with distilled water, that is wrong. We have to wash it with the solution we are going to add to that burette. Filling the burette up to 0 mark with the solution. This is also very important. When you go for chemical laboratory, you will see that burette. Burette is actually very important glassware we are using in the laboratory, right? So this is the way of burette. And here we have a tap. This tap is known as stopcock, right? This tap is known as stopcock. And the specialty of burette is calibrated in this way. Here 25 and 0 is above. 25, 24, 23. Likewise, descending order. Descending order. 25 here and 0. That is the way of calibrating a burette. I still can remember that in my first day of the university, I broke a burette because I don't know how to handle the burette. Right? So you should be able to understand how to handle these things. So here we have very sensitive stopcock. You have to what? Right? So then only you can take the correct volume of the burette. So this is the way that they have calibrated the burette. You can see that. So when you go to school, you will see that you can take the burette and you can watch it, right? So filling the burette up to 0 mark with the solution. No need. No need to fill the burette up to the 0 mark. We can use any kind of volume. Third statement, washing the titration flask with the solution. That means acid or base to be taken to it. Yes, correct. That is correct. Number 4, washing the titration flask only with distilled water. No, no. Not only with distilled water. We have to wash that one with the solution. We are going to add that. Measuring temperature of the solution in the titration flask. No need to measure the temperature of the solutions. Our intention is to do the titration and to find out volume, number of moles of concentration, that kind of a chemical parameter. So therefore, no need to measure the temperature, right? Okay, so simply, idea is this. Summary is actually, when we are using glassware, you have to wash that one using distilled water, and from the solution, we are going to add it. So according to that theory part, we can go for the answer, third one. Question number 10, answer is third. This is really simple theory part. Okay. So if you want, you can draw this setup quickly. Right. Okay. So do you have any doubts? If you have any doubts, let me know that. Put your doubts in the chat box. So it means which is the step we should more consider. Should more consider. Yeah. That is the step you have to consider, right? The answer that I gave you. Right. Now let's move for the question number 11. Question number 11. Which of the following statements is false regarding electromagnetic waves and its spectrum? Can you remember the electromagnetic spectrum? Okay, let's quickly revise the theory point. Question number 11. Electromagnetic spectrum. Right. So the electromagnetic spectrum is starting from TV and radio waves, the lowest frequency, radar waves. I'm writing it the correct order. Microwaves, right? What about the next one? Infrared radiations. Okay. And then visible light, ultraviolet, X-rays, and the highest frequency energy radiation, gamma rays. Now we can include here for this list, cosmic radiations also can be included. Cosmic rays can be found in space, but we can consider that one also. Right? So this is the electromagnetic spectrum. So you can see that for down, from TV waves to radio waves, if you start from there, so frequency is increasing. New frequency increases, therefore energy increases too. And then we can say lambda wavelength decreases. So these are very important, you have to understand. Right? Electromagnetic spectrum. Now, gamma rays, gamma is a highest frequency electromagnetic wave. Yes, that's correct. Gamma rays. I told you that cosmic rays is not included in the electromagnetic spectrum that we discussed, but gamma rays is the highest one. Okay. Second one, wavelength of violet color in the visible region is longer than the wavelength of green color. Visible light region. What are the colors of visible light region? Starting from red. Next one, there are 7 colors, rainbow colors. Can you remember? 1, 2, 3, 4, 5, 6, and 7th one. Okay. Red, orange, yellow, green, blue, indigo, violet. For this direction, frequency and energy increase, and lambda wavelength decreases. Very easy, eh? These are simple theories we learn, isn't it? So wavelength of violet color is wavelength of the violet color in the visible region is longer than wavelength of green color. Is that correct? Who has the highest wavelength? Green and violet. So green has the highest wavelength. So therefore that statement is wrong. So that should be the answer because they're asking false statement. Number 3, speed of any electromagnetic wave in the vacuum is same as speed of light. Yes, that's correct. Speed of light 3 × 8 meters per second. We learned that. Transmission of energy through the space occurs in the form of electromagnetic waves? Yes. So that's why we discuss about these electromagnetic radiations. Everything around us is electromagnetic radiations. Sunlight, electromagnetic radiation. The light coming from these bulbs, electromagnetic radiation, right? So the heat that we feel, electromagnetic radiation. Everything is electromagnetic radiations. Microwaves are used in mobile phones. Yeah, I told you that when I'm discussing this one. Microwaves are especially used in uh, mobile phones, right? So therefore, the false statement is second one. Question number 11, answer is second. Very easy. Question number 11, answer is second. Right? Shall we move for the next question? Question number 12. Question number 12, that is related to the ionization energy. Which of the following answers? So this is the theory point related to that question. If you want to write down these quickly, quickly you can write down it. Question number 12 is related to the ionization energy. Let's see. Okay. Ionization energy graph. Can you remember it? First unit, ionization energy. What does mean by ionization energy? Ionization energy means simply the minimum energy, right, that is required to remove an electron from atom. That is known as ionization energy. So we can see that ionization energy graph contains a zigzag variation. It is containing a zigzag variation. Helium here. If I consider lithium here, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Right? So here helium, lithium, beryllium, boron. And we can see the same variation in the third period elements also. Zigzag variation, isn't it? In this way. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, and potassium, calcium also go down, right? And I told you that according to your resource book, oxygen and hydrogen, both of them are in the same horizontal plane. They have the same value of ionization energy. And as a summary, I told you to remember this table. Remember this table. Look at this only. Highest ionization energy in which group? Lowest ionization energy in which group? If we consider the consecutive ionization energies, I1, I2, I3, these three now, tell me the first ionization energy is high in which group according to the graph? According to this graph, you can see that always the peaks are containing noble gases, helium, neon, argon. So therefore, highest first ionization energy belongs to group number 18 elements. And lowest first ionization energy belongs to group number 1 elements. And if you consider the second ionization energy, lithium go here, beryllium come here. So therefore, highest second ionization belongs to group number 1. Lowest second ionization belongs to group number 2. Highest third ionization energy belongs to group number 2. Lowest third ionization energy belongs to group number 13. So likewise, we can remember this table. This is very important. Using the first ionization energy graph, you can derive the second and third ionization energy graphs also. I told you, right? You have to shift the elements to left-hand side. Lithium will come here, beryllium will come here, and then you can obtain the second ionization energy. If you want to derive the third ionization energy graph, you can move the graph another time. Move the elements. So you have to remember this theory point related to the first ionization energy. Quickly. This is the theory point. So they're asking which of the following answers represent the correct variation of first ionization energies of the elements. What are the elements they have given? They have given boron, carbon, magnesium, silicon, and oxygen. Students, you can see that boron, carbon, oxygen, these elements are in second period. Normally, second period elements have the highest ionization energy. Then oxygen, then carbon, boron. Third period elements have low ionization energies. So therefore, magnesium and silicon, if you compare it, silicon has the highest and lowest belongs to magnesium. So where do you can see this variation? You can see this variation in the second answer. Question number 12, answer is second. Question number 12, answer is second one. Quickly. And if you have any doubts, let me know quickly. Any doubts? Yeah. Yeah, we have to consider in that way. Because fifth one. Why fifth one? Silicon has the greatest ionization energy. So we consider second period elements they have the highest ionization energies than third period, because one energy level is increasing if you go for the third period. So therefore, we can easily remove electrons. Okay. Right. Now let's move for the question number 13. Question number 13 also chemical calculation part question. Let's see how to do this question. That's also very easy. Right. So I believe that you can remember the theory, simple theory point that I taught you. Number of moles is equal to mass divided by the molar mass. So by keep this equation in your mind, let's go for the question. So there is a sample which is weighed as 4 grams. This sample is containing sodium carbonate and sodium nitrate. Only sodium carbonate and sodium nitrate. Okay. And this sample was dissolved in a beaker by making the volume up to 100 cubic centimeter aqueous solution. Then students, they have added barium chloride to this solution. Barium chloride concentration is 0.1, right? So remember, I'm always recommending that when you're doing a calculation question, you can draw a simple diagram to understand the question, because some students can't understand when you read this question at once. Neither. So therefore, you draw a simple diagram and try to figure out everything one by one. Then you will get a clear image about the question later. Then you can continue the calculation. Directly, if you are trying to do the calculation, sometimes you will get stuck. Neither. So therefore, to avoid that, you draw a simple diagram and explain that on to yourself, right? So then barium chloride is added. So when barium chloride is added, they have obtained a precipitate. When you add barium chloride to the solution, a precipitate, a solid is formed, a new solid. Let's see what is that, okay? That solid mass is 5.91 grams. Mass percentage of sodium nitrate in the sample. Sodium nitrate mass percentage, right? How do you find? They have given hint. Only barium carbonate is a precipitate, but barium nitrate is not. They have given that barium carbonate is a precipitate. That means when sodium carbonate is reacting with barium chloride, it's forming barium carbonate. Barium carbonate is white color precipitate, students. And here sodium chloride is formed. Got it? Then they have indirectly told us that this mass is, this solid precipitated mass is nothing else barium carbonate. Right? Indirectly, they have given that. You have to understand it. Right. Since mass is given, let's find out the molar mass of barium carbonate. What is the molar mass of barium carbonate? Molar mass, barium is 137, carbon is 12, oxygen is 16 into 3 grams per mole. And now get the summation. 16 into 3 is 48 plus 12, 137. So the answer would be 197. Okay. 17,169, yes, 197 grams. According to that equation, can't you find out number of barium carbonate moles? Yes, we can. Mass divided by molar mass gives us number of moles. Grams cancel off. 591 divided by 197. We can see that 197, if you multiply this one by 3, 21, 2 here, 27, 29, 2 here, fine, yeah, 591. Correct. So therefore, answer should be 0.03. Remember, in the examination, they are giving always simplified value. They won't give you difficult calculations because they are expecting you to get the answer by using correct theory knowledge, not the calculations, right? Calculations are really easy, but you should know how to use the logarithms to get the answers for difficult calculations, right? Barium carbonate number of moles. These are the barium carbonate number of moles. Then what is the carbonate number of moles? In one barium carbonate, one carbonate is there. So if that is 0.03, carbonate moles are also 0.03. Carbonate moles are also 0.03. Right? Very easy. This carbonate came from, students, this carbonate came from sodium carbonate. If the carbonate moles are 0.03, sodium carbonate moles also 0.03. So why you are finding sodium carbonate moles? Because they are asking mass percentage. So therefore, we need to find out the total mass. Right? We have to, total mass is given. Sorry, total mass is given. We have to find out sodium carbonate mass. Then only we can find out sodium nitrate mass. Okay? Molar mass of sodium carbonate is 106 grams per mole. Then find out the mass of sodium carbonate, 0.03 multiplied by 106. So the answer is 3.1. That is the mass of sodium carbonate. We know the total mass. Since we know the total mass, now we can get sodium nitrate mass. 4 grams, subtract the mass of sodium carbonate, then you will get the answer. 0.82 grams. This is the mass of sodium nitrate. How do you find out sodium nitrate mass percentage? Total mass is 0.4 grams. Out of 4 grams, 0.82 grams is sodium nitrate. That is multiplied by 100%. Total mass, here we have sodium nitrate mass. Sodium nitrate mass divided by total mass multiplied by 100. Then 82 divided by 4%. Divide 82 by 4. So here we have 2, 0, 2, 4, 0, for 25. 20.5%. 20.5. 13 answers. If you have any doubts, anything, tell me. I will help you. Students, you must practice these questions. Believe me, mark my words. Any doubts, anything? Right, okay. Look at this one. We have calculated barium carbonate mole 0.03. Inside one barium carbonate mole, there is only one carbonate. So therefore, barium carbonate and carbonate moles are equal. Both of them are equal. So this carbonate initially came from where? Sodium carbonate. So therefore, sodium carbonate moles are also same amount. So that is also 0.03. Can you understand? That is how we got obtained 0.03, right? If you have any doubts, put your doubts in the chat box quickly. right? So I believe you don't have any doubts. If you have any doubts, tell me. Right. So let's go for the question number 14. Question number 14 is also a calculation question. Let's see. Density of 1 moles per cubic decimeter solution. So please correct it as density of 1 moles per cubic decimeter. Okay. So 1 is not printed there. It should be corrected as 1 moles per cubic decimeter. Solution of a compound, capital A, having the molecular mass of 58 is 0.85 grams per cubic centimeter. What is the molality of the solution in moles per kilogram? Okay. Now I'm going to teach you the theory point that is related to this question. If you can remember this theory, if you can know this theory, if you know this theory, question is easy. Molality, right? So molality of a solution is defined by, right, number of moles of solute divided by mass of solvent. So this is actually considered as what? Molality. Right? Now just imagine a sodium hydroxide aqueous solution. So in sodium hydroxide aqueous solution, who is the solvent and who is the solute? Do you know how to compare the solvent and solute? Solvent is water. Solute is sodium hydroxide. Likewise. Okay? Solvent and solute. So the theory point is molarity is equal to number of moles of solute divided by mass of solute. Now, this is enough. Now we can find out the molality of the solution. How we can find out? First of all, they have given that concentration is 1 moles per cubic decimeter. Can you remember I told you that concentration is equal to number of moles divided by the volume. Okay. So let's consider 1 cubic decimeter volume of solution. Right? Let's consider 1 cubic decimeter of solution. Then what is the number of moles of solute? What is the number of moles of solute? Because we know that concentration is 0.1 moles per cubic decimeter. If you multiply the concentration by volume, you will obtain the number of moles. That means, students, there is only 1 mole of solute. Right? There is only 1 mole of solute according to this N C equal N over V. And the next one is they have given the molar mass. So molar mass means, so we know that N equal the theory point that we learned, mass over molar mass. How we can find out the mass of solute? Mass of solute? Number of moles, 1 mole. Molar mass is 58 grams per mole. This is the unit of molar mass. Then mass of solute is 58 grams. Solute. What is the mass of solvent? So they have given the density of the solution 0.85 grams per cubic centimeter. And the volume is, I consider that is 1 cubic decimeter. That means 1000 cubic centimeters. I told you that 1 cubic decimeter is equal to 1000 cubic centimeters. Then cubic centimeter per cubic centimeter will cancel off. Then the mass of solvent is 858 grams. This is the mass of solvent. Okay. So what I have done, very easy. I'm considering 1 cubic decimeter volume of the solution. Then we can find out the number of moles of solute, because concentration 1 moles per cubic decimeter multiplied by the volume, then you will obtain number of moles according to C equal N of V, right? And then according to this equation, we can find out the mass, because number of moles 1 and multiplied by molar mass, then 58. Then this is the solvent mass, solute mass and the solvent mass. Okay, got it? No, we have to consider volume is 1 cubic decimeter. If not, we cannot go for the answers. Because in order to find out the molality, what are the two parameters we need? Number of moles of solute and the mass of solvent. Moles of solute we have obtained 1 mole. How did you obtain that one? By multiplying the volume. Therefore, we need to take volume as 1 cubic decimeter. The unit volume is 1 cubic decimeter. Can you understand? Huh? Hypothetically, yes, we are assuming. We are assuming we have 1 cubic decimeter. And this is the mass of the solvent. Then these two parameters are enough. Right? And now I'm going to substitute for the molality. Number of moles of solute, just 1 mole. Give me a minute, students. Is this mass of solvent or mass of solution? This is mass of solution. Solution, isn't it? They have given the density of the solution. If you multiply that one by the volume, this is the mass of solution. Then how do you obtain the mass of solvent? How do you obtain the mass of solvent? Yes, very good. Very good. Remember, mass of solute plus mass of solvent is equal to what? Mass of solution. Then can't you obtain solvent mass? Solvent mass is equal to 858 grams minus 58 grams. So the answer is 800 grams. 800 grams. Okay. And the next thing, remember students, the unit of molarity is always moles per kilogram. What is the unit of molality? Moles per kilogram. That means we have to take the mass of solvent always mass of solvent in kilograms. Okay. Then how do you write down 800 grams in kilograms? 0.8 kilograms. Then you will get the answer 1.25 moles per kilogram. This is the molality. So don't worry, students. I'm going to upload all the answers, right? I'm going to upload the answer sheet for this one. That means how to do the calculations. How do you follow these steps? Again, with the theory points, I'm going to upload it very soon. So you just copy down these things and try to understand what I have taught you. If you have any doubts, let me know. So this is question number 14. Quickly copy this. Remember, always we are representing this concentration for solute. That means this 1 moles means solute number of moles. Okay. Right. Okay. So question number 14 answer is second one. Right. So now time is 6. I'm going to wind up the session for today. So students, do you have any doubts? Anything you want to ask? So the remaining questions will be discussed in the next session. So next Monday also same time we are going to discuss so the questions. But before that, tell me, do you have any doubts regarding the questions that we discussed today? Actually, we discussed very good questions. I believe that you got a good knowledge, right? Yes. Yeah. Okay. Thank you, Nasma. Thank you. Right. So Senanga, you have doubt. Eh? What is it? So can you explain how you got the mass of the solution again? Mass of the solution again. Yes, easy. Look at this. Students, they have given the density. Density, and I told you that volume, I should consider that one as 1 cubic decimeter. So density is equal to mass divided by volume. Then can't you obtain the mass? Mass equal density multiplied by volume. That's very easy, right? 1 cubic decimeter is equal to 1000 cubic centimeter. I told you the connection. So is this for us also right? Gafur, there is a separate paper class for 24 batch, which is conducting on Sunday morning. So this paper class is for 25 batch. But if you want to join for this one, you can join for this one. If you want to join for 24 batch paper class, you can join for that, right? Right. Okay. Then let's meet on next Monday. And if you can put a comment or any suggestions about this class, so put your doubts, maybe any suggestions, comments about the paper class, today paper class to WhatsApp group. Okay. So let's see. Okay, then let's meet on next Monday, same time. Until then, bye bye. Have fun. You can leave. Okay. God bless you. Bye.